Hi everyone. So our today's topic of discussion is permutation and combinations basics. Okay. So a lot of students have been messaging me that they want a detailed video on permutation and combination. So here we go. So this is basically the first lecture of PNC basics. So what we'll be doing in this lecture or in this video is that I'll be explaining you what exactly is meant by P and what exactly is meant by P. Like, what do you mean by permutation? What do you mean by combination? We'll understand the two terms in detail. Then we'll also understand the method, that is the counting method. Like, if you are unable to use permutation and combination in a particular question, then there is another method that is known as counting method, which helps us. Okay. Then we'll look at the similarities between the two concepts, because these are like two different ways of finding out an answer and nothing else is there. And then we'll solve a couple of questions so that we're able to relate the concepts with the question. Now there is one suggestion from my side. I'll be explaining you the basics, no doubt in that. I'll be giving you the formulas also. I'll be giving you all the relationships also. There is one thing which you need to understand as far as permutation and combination is concerned. That is your basic understanding of a question and your logic on how to approach the question is required in this chapter. This chapter is not about simply knowing what is C, what is P, how do you use Ncr, Npr. You all must have done this. There's nothing new in this. But how do you approach a question? How do you solve a question? That's more important. Okay, understanding a question and your approach, that's more important. So keep your logics or keep your mind aware. That's more important in this chapter. Okay. All right. So let's begin. So let's start with what is C and what is P. So if you already know the basics, then you can jump on to the questions. If you want to know the basics, because I'm going to give you a detailed explanation of everything, then you can start from here also. So what is C and what is P? Let's try and understand. The word C basically stands for combination. And the word P basically stands for permutation. Now these are not two different things. There is a similarity between both of them. So we'll try and understand. First, we'll try to differentiate them so that you understand the concept. Then I'll also explain like what's the similarity, how are the two things connected, and you'll also realize that this is the parent concept, and this P has basically evolved from C itself. Okay. So slowly and gradually you'll start understanding what exactly they are. So don't worry about it. It's a long way to go as far as P and C is concerned. All right, so we have C on the one side and we have P on the other side. So in order to understand both, let's take an example and let's use our logic. Let's say we do not know what is C, what is P. Let's keep that aside. Let's simply use our logic. Okay. So my first statement is, let's say suppose I have a class of 15 students and I wish to call three of them on the stage. Any three of them, let's name three of them to be A, B, and C. I have a class of 15 students and I wish to call three students on the stage, or I wish to select three students, let's call them A, B, and C. Now the question is, does the order matter of calling A, B, and C? Like what I mean to ask is, does it matter whether I call A first, B first, or C first? Does that order of calling matters? So if we think about this logically, the order of calling them on the stage would not matter. Like it doesn't matter whether you call A first or B first or C first, because all three of them will be on the stage. So whenever the order doesn't matter, whenever the order doesn't matter, it becomes the case of combination. Whenever the order doesn't matter, it becomes the case of combination. The formula for combination is given as NCR, where N stands for total and R stands for your requirement. So when I say I have a class of 15 students and I wish to call 3 of them on the stage, or I wish to select 3 of them, let's call them A, B and C. So what I'm saying is, I'm basically saying that I have a class of 15 students and I'm selecting 3 of them. So that will simply become 15C3. Or you can understand it in this way. I have a total of 15 students and my requirement is 3 students. So that's 15C3. Now how do you solve NCR? NCR is solved as n factorial divided by n minus r factorial into r factorial. So using this, you'll get your answer as 15 factorial divided by 12 factorial into 3 factorial. Now, how do you expand factorial? So let's take an example of 5 factorial. So 5 factorial is basically 1 into 2 into 3 into 4 into 5. So n factorial is basically like sum of all the natural numbers from 1 to n itself. So if it is 10 factorial, then it's 1 into 2 into 3 into 4 into 5 up to 10. This is what is meant by, this is how you expand factorial, okay? Like if someone asks you what is the meaning of factorial, so factorial basically tells you the number of ways in which you can arrange things. So let's leave that, but this is how you define factorial, okay? How do you expand it? This is the way to expand it. So there's a difference between definition and expansion. So this can be rewritten as 13 into 14 into 15 divided by 1 into 2 into 3. So from there, whatever answer you're going to get, let's suppose your answer comes out to be x. Let me do one thing, let me remove this line. Let's first discuss combination only. So let's say this is 3 goes, this becomes 5, and this 2 goes and this becomes 7. So you're basically, it's gonna be 13 into 7 into 5, so that's 13 into 35. So that's 350 plus 105. So 350 plus 105. So that will be 455. Now the question is, what do you mean by this 455? What do you mean by this 455? Or like, what do you mean by this 15C3? When you write 15C3, what does that mean? This is important for you to understand. Because unless and until you understand this, you'll blindly start using Ncr and Npr. You need to understand what is meant by 15C3. When you write 15C3, that basically means, that basically gives you the number of ways in which you can select any 3 things out of 15 different things. 15C3 basically tells you the number of ways in which you can select any 3 things out of 15 different things. So what is 455 here? 455 here is basically, there are 455 ways in which you can call any 3 students out of a given of 15 students. There are basically 455 different ways in which you can call any 3 students out of a given of 15 students. This is the literal meaning of NCR, or 15C3 in this case. Let's suppose if you have only 4 students and if you wish to call any 3 of them on the stage, so your answer simply becomes 4C3, and this will be 4 factorial by 1 factorial into 3 factorial, which will come out to be 4. So there are basically of 4 ways in which you can call any 3 students on the stage, and you can check this manually also. Let's suppose the 4 students are A, B, C, D. Now the order doesn't matter. So what are the ways? I can call A, B, C. That's one way. I can also call A, B, D. That's second way. I can call A, C, D. That's third way. And I can also call B, C, D. That's fourth way. Apart from these 4 ways, there is no fifth way in which you can call 3 students out of A, B, C, D on a stage. I have covered all the ways. So this is how you define combination. This is how you define combination. Okay. Now remember that whenever you will be solving a question, in the question it will not be given to you that you need to use the formula for combination or permutation. So there are some keywords which will help you, which will guide you. Apart from that, like once you'll start solving questions with the help of logic, you'll start understanding whether I have to use combination or permutation, all those things. But yeah, keywords do help us sometimes. So the keyword for the combination is the word selection. The keyword for the word combination is the word selection. And we can think about this logically also, that whenever you select thing, the order doesn't matter. Whenever you select things, the order doesn't matter. For example, let's suppose I have 5 players and I wish to select any 2 of them. Let's suppose the 2 players I wish to select are A and B. Now whether I call A first or whether I call B first, it doesn't matter, because I'm selecting 2 players and one of them is A, the other one is B. So whenever you use select things, for example, you can select a committee of 5 members out of 10 members. So let's say the 5 members that you want to select are A, B, C, D, E. Now whether you select A first, B second, C third, D fourth, E fifth, or whether you select E first, D second, C third, B fourth, or A fifth, it won't matter. The order won't matter. Whenever you are selecting things, the order won't matter. So that becomes a case of combination, and the formula for combination is NCR. N is total, R is requirement. So what is NCR? It gives you the total number of ways in which you can select R things out of a given of N different things. This is the literal meaning of NCR. Alright. So let's move on to the next thing, that is permutation. So next is P, that stands for permutation. So let's take an example again in order to understand this. Now let's say there is an Olympic race, and in that race there are 10 participants who took part in the race. Now think logically and then answer. Would it or would it not matter in which order those participants will be finishing the race? Would it or would it not matter in which order the participants will be finishing the race? Now in this case, if you think logically, in this case the order would matter, because the person who's going to come first, or the athlete who's going to come first, is going to get the gold medal. The second one is going to get the silver medal, and the third one is going to get the bronze medal. Okay. So whenever the order matters, it becomes the case of permutation. Whenever the order matters, it becomes the case of permutation. The formula for permutation is given as NPR, which is equal to n factorial divided by n minus r factorial, which is equal to n factorial divided by n minus r factorial. So if there are like 10 participants who took part in the race, and we're looking for the first 3, then this will basically become 10p3, which is equal to 10 factorial divided by 7 factorial, which will basically be equal to 8 into 9 into 10, and that's equal to 720, and that is equal to 720. Now what do you mean by this 720? So if we understand this in detail, what basically is meant by this 720? This 720 basically means that out of the 10 participants you have, in how many ways, can any 3 participants finish the race in the first 3 places? In how many ways can any 3 participants finish the race in first 3 places? Now, when I say first 3 places, the order matters. Let's say suppose I say that A, B and C finish the race in first 3 positions. Now it can happen, let's say that first position, second position, third position, it can happen that A came first, B second, C third. It can also happen A came first, C second, B third. It can also happen that B came first, A second, C third. It can also happen B came first, C second, A third. Or we can have CAB and CB. So the order matters. The order here matters. So when you say 10p3, that means in how many ways out of 10 participants any 3 of them can finish at the first 3 positions. So in this case, it's not about selection because the order matters here. It's also about arrangement. It is also about arrangement. Hence the keyword for permutation is arrangement. Because whenever you arrange things, the order matters. Whenever you arrange, the order matters. For example, in how many ways can you arrange 3 children on 3 chairs? So let's suppose the 3 children are PQR. So then it matters who is sitting at the leftmost position, who is sitting at the central position, and who is sitting at the rightmost position. You can have PQR, PRQ, QPR, QRP, RP, QRQP. Okay. Another way of understanding this permutation is that out of 10 participants, you need 3 participants for the first 3 positions. So why don't you do it this way? Out of 10, you select 3. You'll get the number of ways of selecting 3 participants. You'll be able to select 3 participants and then multiply this selection by the number of ways in which you can arrange these 3 participants, and multiply that by the number of ways in which you can arrange these 3 participants, because that's the additional thing I'm doing. Apart from that, there is no additional thing that I'm doing. I'm selecting 3 and then I'm arranging them, that's it. So when you talk about NCR and NPR, so if I talk about this term NCR, so I wrote the formula for NCR as n factorial divided by n minus r factorial into r factorial, and when I spoke about NPR, that was equal to n factorial divided by n minus r factorial. So you can very well see that the only difference is this r factor in the denominator. So if I multiply this expression by r factorial, then this expression will again become NPR. And I'm be multiplying r factorial here also. So you select and then you arrange. That becomes permutation. You simply select it becomes combination. You can say that from here that NPR is equal to NCR multiplied by R factorial. Now what is this R factorial? What is this additional thing? That is simply arrangement. That is simply arrangement. So when I told you that when we were discussing 5 factorial, okay, you expand 5 factorial as 1 into 2 into 3 into 4 into 5, that's fine. But what does that mean? So R factorial basically means arrangement after selecting things. So when someone says what is n factorial is basically the arrangement of n things. N different things. Let's use that word, correct word, n different things. So what is R factorial here? It's like arrangement of R different things. So the parent concept is combination, but when you arrange also after selecting things, it becomes permutation. So this is the basics of permutation and combination that you need to know, like the basic definition. Now sometimes what happens, even after knowing the basic definition, we are still unable to figure out whether the question is based on permutation or combination, because that they will not mention in the question. So for that we understand one more way, another method that is known as the concept of counting method. Okay, so there are two things you need to remember, that is whenever we will be using the word and, whether used by us or whether mentioned in the question, whether the word and is used by us or whether it is mentioned in the question, the word and always stands for multiplication. The word and always stands for multiplication. Similarly, the word or, this always stands for addition. The word or always stands for addition. Okay, just remember these two things. So let's take an example in order to understand this. So what we can do is, let's say there are 4 cities A, B, C and D, and these are the paths by which you can go from a city to the another city. This is how they are connected. And let's say I live in city A. These are the only paths, okay, by which you can go from one city to the other city. There is no another path available. Let's say I stay at city A. So my question is, in how many ways can I go from city A to city D? In how many ways can I go from city A to city D? So pause the video and try the question yourself first. Alright, so what we're gonna do is, we're gonna solve this question using both the ways. One is the counting method, that is like simply counting. And second is we're gonna do this question with the help of PNC also, so that you understand there is no difference, it's just different ways of solving a question. Alright, so first is the counting method. So what I'm gonna do is, I want to go from A to D. Okay, if I want to go from A to D, so what I can do is I can break this into pieces. That is, if I want to go from A to D, then it should be A to B and B to C and C to D. Okay, so I have broken this into 3 parts: A to B and B to C and C to D. Now if I want to go from A to B, can I say there are only 3 possible ways? That is path 1, path 2 or path 3. There is nothing else that I can do. These are the only 3 ways available to me. If I want to go from B to C, I have only 2 ways. And if I want to go from C to D, I have only 3 ways. Now if you want to go from A to D, you have to go A to B and B to C and C to D. And what does AND stand for? AND stands for multiplication. So this is going to be like 18 number of ways. This is going to be 18 number of ways. Now you can solve this using combination also. Again, let's break it into three parts: A to B and B to C and C to D. Now if I talk about A to B, can I say I have three ways and I need to choose one, because at a time I can only use one path. So that will give me 3C1 ways. That is, I have a total of three ways and I wish to select one. So that is simply 3C1. If I want to go from B to C, then I have two ways and I can only select one, so that's 2C1. Or if I want to go from C to D, then I have three ways and I wish to select one, so that's 3C1 again. 3C1 is 3, 2C1 is 2, 3C1 is 3. So again you're gonna get that there are 18 number of ways. There are again 18 number of ways by which you can go from A to D. Now you can solve this question using OR also. It's not that you can only solve this question using AND, you can solve this question using OR also. Let's see how. So let's name the path. Let's say this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, and this is 8. Now, if I want to go from A to B, I can do it in three ways. Either it's the first path, or the second path, or the third path. And OR stands for addition. I'm going to put an addition sign. It has to be either first or second or third. Now, if I use the first path and if I have reached B, then I have two possibilities with me, 4 or 5. I have two possibilities with me, that is 4 or 5. Same thing goes for second also, that is 4 or 5. And same thing goes for third also, that is 4 or 5. This is the only thing that I can do. Now for each of 4 or 5, I have three paths, that is 6 or 7 or 8. Same thing goes for this one also. And same thing here also, 6 or 7 or 8. Same thing goes here also. The same thing, 6 or 7 or 8, and the same thing goes here also. Now when you say OR, it stands for addition. So 6, that is one way, 7, that is another way, 8, that is third way. So how many ways? Three ways. Going by 4, 3 into 1, that's 3, and multiplied by 1, that will again give you total of 3 ways. Same thing for this, 1, then 5, then 6 or 7 or 8, again 3 ways. Then this will again be 3, this will again be 3. Same here. So when you start with 3, you go to 4. When you go to 4, then it's 6 or 7 or 8, again 3 ways. Then when you from 3, if you go to 5, then again you go at the same way, 6 or 7 or 8, that's again 3. So 6 ways for this, 6 ways for second, and 6 ways for first. And in the middle you have a plus sign, so 6 plus 6 plus 6, that's 18 ways. So it doesn't matter which way you do it. There are simply like different ways of solving a question. Which way suits you and which way is the shorter one, that depends on the question. Like I can make this question a bit difficult also. So let's suppose if I say that so let's add one more way from here. Let's add one more way from here. So the question is, in how many ways can you go from A to D? Now you have to break this question into 2 or 3 parts. Let's see how we can solve this one. So the first way is basically the direct way. First way is the direct way. That is, you directly go from A to D, it's fine. Second thing that you can do is, because now it's direct way or the other way, I'll have to put an addition sign. Then you will go from A to B. Now if you go from A to B, there are three possible cases: path 1, path 2, or path 3. Now you have reached B. Now you have reached B. Now once you reach B using any of the three paths, one of the ways in which you can reach D is you can take this direct path, that is from B to D. You can go using the direct path. So three ways. Or what you can do is, again plus you have reached B, and then you go the conventional way, that is 3 into 2, that is B to C, and into 3, that is C to D. So 3 into 2 into 3 is basically 18. 18 and 3 is 21, 21 and 1 is 22 ways. So there are 22 ways in which you can go from A to D. You can do this also. So the point is, it depends on the question. So in this case, I've used both the concepts, and as well as or. Wherever or was required, I used or. Wherever and was required, I used and. Okay. Let's take up one more question for the basics. So there is an examination, and this examination basically consists of 4 true false mandatory questions, 3 4 options MCQ questions which are not mandatory, and 4 fill in the blank questions, or let's not take fill in the blanks, let's take match the following questions. For which you have 6 options or 6 answer choices. And any question can have any of the answers. Like, what I mean to say is that if, let's suppose, you have 4 questions, 1, 2, 3 and 4, and you have 5 answer choices: A, B, C, D, E and F. So A can have an answer as A. It's also possible that 2 can have answer as A, 3 can have answer as E, and 4 again can have answer as A. Not B, it's A. 4 can again have answer as A. So one option can be answer to multiple questions. One option can be answer to multiple questions. So I have 4 true false mandatory questions which I need to solve. 3 questions having 3 MCQ questions with 4 options which are not mandatory, and 4 match the following questions having 6 options or 6 answer choices, and an option can be answered to any number of questions. The question is, in how many ways can an aspirant mark the answers? In how many ways can an aspirant mark the answers to these 11 questions. So pause the video, try it yourself, then play back the video in order to understand how to solve this question. Okay, take your time. All right, let's see how we can solve this question. I think I missed out on one thing. The match the followings are also mandatory. Okay, so match the followings are also mandatory. But anyways, if you have done it with non-mandatory also, I'll still let you know what's the answer. Don't worry about it. All right, so let's see what we can do. So the first one is 4 true false question with mandatory questions. So first of all, let's understand what do I mean by in how many different ways can an aspirant mark the answer. So I'm going to make you understand this with the help of 4 true false questions. Okay. So let's say there are 3 aspirants who go and sit in the exam. Let's call them X, Y, and Z. Okay, let's call them X, Y, and Z. The first one marks the 4 answers as true, 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 false. The second one marks the answer as false, true, true, true. And the third one marks the answer as true, false, true, true. Now if you'll observe carefully, you'll realize that all 3 of them have marked 3 true and 1 false. All 3 of them have marked 3 true and 1 false. But the order in which they have marked, that's different. The order in which they have marked is different. The first one has marked the fourth one as false, the second one has marked first one as false, the third one has marked second one as false. So I'm talking about these number of ways, like how many ways are there to mark the answers. Okay, so let's start with the true and false one. So all 4 questions are mandatory. Now I can say that all the 4 questions are independent and answering any one of them is not dependent on the other question. Like what will be the answer to the first one or how will you mark the answer to the first one is not dependent on the second question. Similarly, marking the answer for the third one is not dependent on the fourth one and vice versa. So let's look at the questions individually. If I look at the questions individually, I can say that there are like 2 ways of marking the first answer. That is, you can either mark it as true or you can mark it as false because the question is mandatory. You can't leave the question. Or if you think of this question in the combination way, you can simply say 2C1. You have 2 answer choices, you need to select one, so that's 2C1. For the second question, again 2 ways, or you can say 2C1. Third, again 2 ways or 2C1. Fourth, again 2 ways or 2C1. Now you want to mark the first and second and third and fourth because all 4 questions are mandatory. So you need to mark first and second and third and fourth, and stands for multiplication. This will give you a total of 16 ways. Now if you have solved it and let's suppose for this case, the true and false case, you say my answer is 4 factorial. This is usually what answers I get, 4 factorial or 4C2. Now why is 4 factorial incorrect? The literal meaning of 4 factorial is that you are arranging 4 different things on a straight line. Now understand, I have not asked you to arrange these 4 questions. That's not my question. My question is in how many ways can you attempt the questions. I'm not asking you to arrange the questions. So that's why 4 factorial is wrong. Second, why is 4C2 wrong? 4C2, the literal meaning of 4C2 is that out of 4 different things, you are selecting 2 things. That's again not my question. I'm not asking you to pick 2 questions. That's why this is also wrong. If apart from this, if you have got anything else also, so do let me know in the comment box. I'll let you know why that is incorrect. Okay, don't worry about it. If you have done 4P2, so 4P2 is like you're selecting 2 and then you're arranging 2 of them. That's again not the thing that I'm asking. So as far as the first one is concerned, that four true false mandatory questions, the total number of ways is 60. The total number of ways is 60. Let's move on to the second one. Second one is three MCQ questions with 4 answer choices, and the questions are not mandatory. So let's look at the question individually. Now, if the questions are not mandatory, that means you can leave a question. So you have the fifth option with you. You can either mark A, B, C, D, or whatever the number of options are, like 1, 2, 3, 4, A, B, C, D. You can either mark A, B, C, or D, or you can leave the question also. That's also a possibility. That's also a possibility. So for all of the questions, for question 1, 5 choices, question 2, 5 choices, question 3, 5 choices. Or you can do 5C1, 5C1 and 5C1. That will simply give you 5Q. Or the first one, let me write it as 2 to the power 4. Second one is 5Q. Again, the same reason exactly, there is no difference. The last one is the 4 match the following questions with 6 options, 6 answer choices, and any option can be the answer to any of the questions. An option can be answer to multiple questions also, and the questions are mandatory. So which means if I have 4 questions, so the first one can have 6 options. The first one can have 6 options. Now an option can be answer to multiple questions, which means for second question also I have 6 options. If in case an option can be answered to only one question, so in place of 6, I'll be writing 5 for the second one. Because one answer that will be taken by question number 1, that cannot be answered to the second, third, or fourth question, so one answer is out. In that case, I would have taken 5 for the second question. But since I specifically told you that an option can be an answer to multiple questions, so that's why I'm taking 6. That's why I'll be taking 6 for the remaining third and fourth question also. If an option can be an answer to only one question, in that case I would have taken this to be 4 and 3. So in this case, the question that I gave you, in this case my answer will become 6 to the power 4. That is 6 into 6 into 6 into 6. If it was the other case, that is an option can be answered to only one question, then it would have been 6 into 5 into 4 into 3. And if it is like not mandatory, then you have an option of leaving also, then it's 7 into 7 into 7 into 7. Now for all these 11 questions, what are the total possible ways? You need to mark the first true and false. You have to like attempt or not attempt the next 3 MCQ, and you have to attempt all the 4 match the following. So when you're using the word and, so it's 2 to the power 4 into 5 to the power 3 into 6 to the power 4. So basically it all depends upon like what the question is and how do you process the information. So as far as the basics is concerned, this is like more or less everything that you need to know. Now what we'll be doing is we'll be solving questions based on the basics that we have covered up. So in the next video we'll be solving questions, and next to that we'll be taking up more questions. So probably like there will be 4 to 5 videos on permutation and combination. Okay, because it's a detailed chapter and mostly people do get confused in this topic, so I thought that I'll make a detailed video, couple of videos on this topic. So guys, if you haven't subscribed to the channel, please do that. Please like and do share the video. Please let your friends also know about this channel so that people can come and people can learn. So if you have any comments, if you have any suggestions, then do please let me know in the comment box. And if you're looking for personalized training or individual coaching classes for SAT, GMAT and GRE, you can always contact me. All right. So that will be all, guys. Thank you so much. Keep watching and keep learning.